Welcome to Mr. South's Math World. Today, we are going to have a look on how to find the primitive function. So do you still remember these questions? So for differentiation, we got a primitive function. So this is called primitive function. And we differentiate, we got a function here. So after we integrate, then we get the primitive function again. But when we goes back in this direction, we actually have no idea what the constant is. So we just call it as arbitrary constant. But in fact, we can have some more information so that we are able to find the information of the primitive function. So how to make it? So let's use this one example. So we let capital letter f of x to be the primitive function, and then we differentiate, we get f of x, alright? So usually we will be given the value. It is given, remember, okay? So it's given a value, for example, f of 2, alright, equals to 7. Then, when we done so, that means originally if your question only gives you this one, then we integrate. That means step 1 we have, okay, so we have integral of 2x dx. Then we know it is x squared plus c. Then the next step will be, as I know that this is f of x, right? A primitive function. Then do the substitution, f2 equals to 7. Then we know that x squared plus, it should be 2 squared plus c equals to 7. So c equals to 3. So what are we finding actually? So when we know the information of c, that means we are able to know what exactly the primitive function is. So it means the primitive function is x squared plus 3. Okay, so that means the objective of this part is to find the primitive function. And if it is y equals to fx, then we will have the equation of y. So let's give you one more example. So this time you are given a second derivative of a function, and we get 4x minus 1 over 3. Then you are given these two pieces of information, and then at last you are asked to express y in terms of x. So that means that for the question we are given the second derivative. So if I want to get it to be y, that means we need to integrate it back step by step, and then the other step goes to y, because this is integration, right? Just say in, for example. And then if we differentiate of the opposite order, we differentiate y twice, and you get this one, second derivative. So we need to integrate and integrate. So let's start. So step 1 is we integrate on both sides. On the left, we just write down this is the integral of d square y of d square, and then integrate 1 by 1. That means 4 times x squared divided by 2 minus 1 over 3x plus c. Then you get 2x squared minus 1 over 3x plus c. And then we need to integrate it again to get the value of y. But this time we need to pay attention. So after you have integrated 1 over 3 times x squared divided by 2 plus cx. So this time, because you already got c as a arbitrary constant, but you know we are going these two, they are different because c goes to the x already, the first constant. Then the second constant don't have the relationship with c. That means they are not the same. So these two, they are not the same. So we need to put a new constant, so which is called c1. And then simplify it first. So what would get the equation of y will be 2x cubed divided by 3 minus x squared divided by 6 plus cx plus c1. So these are the process of integration. So step 1 is done. So after that, we are going to substitute this value into this equation to find the value of c1 and c, so we can express it. So right now you'll get this equation. So substitutions goes. So substitute the first one, and you will get this equation, right? So the unknown are c and c1. So we need to form an equation for them, like this. So you get equation 1 here. So let's do it similarly for equation 2, which is we substitute x equals to 4 and y equals to -1. Then we simplify it. And then you will get 4c plus c1 equals to -41. And then we get it as equation 2. So finally, we solve the equation for c and c1. Then this time we can use method of elimination, because just have 1 minus 2, then we already able to find the value of c. So solve it. So you can find the value of c. Substituting back to equation 1, and you will get the value of c1. And then we can do it for substitution at last. So therefore, copying the value. And then you get y equals to 2x cubed divided by 3 minus 6x squared divided by 6, and then minus 73 divided by 6x, and then for the c1 will be -50 divided by 3 as the final answer. So please bear in mind that this is an equation. So when it is an equation, it means that c and c1, all the arbitrary constants there must be arbitrary, except for arbitrary constants, because they are no longer arbitrary, because we can find it. So this time, finding the primitive function, that it also means that we are able to find the equation. So that's the end of this session. See you next time.